All right, guys, I've got the recorder on. Welcome to Calculus BC. Hopefully, this doesn't give any of you too many terrible memories from learning over COVID because this should look familiar. Um, so when we're doing this here, so just to kind of talk to you guys for a minute or two before we jump in. So I'm going to do my best here. As far as I know, I can record all of these sessions and we will get them uploaded. I believe I'm going to have access to your Canvas pages that were set up through Mr. Kokonis. So shouldn't be an issue there. If you can, turn the video monitors on. If you absolutely can't, that's cool. But it makes it easier from my end just to see some faces and get some conversation going versus me just kind of staring at blank Zoom screens. So if you don't mind, when we're doing this, turn your video on and we'll talk and try our best to record all of this and take all of your questions. And if I were you guys, I would get a totally separate notebook or system or folder or whatever you want to do for this BC material. So that way you can just totally keep track of the stuff we do on these night sessions. But obviously you got to know all the AB stuff as well. But I think it would just be best that you don't mix this into your AB stuff. So you can kind of keep separate because obviously this is a different type of learning when it's just on Zoom versus in class. So that way you kind of separate the two and hopefully that'll help with your questions and stuff like that. Does anybody have any questions for me or anything on your mind before we get started? Okay, so tonight, I don't know, some of these sessions will be longer than others. We're not in a race and we're starting earlier than we usually would. Um, I don't think I started actual BC material last year until mid to late February. So we're going to go pretty slow. We're not in a race. This way it'll give us some time, just kind of fill this out, see how it goes. So tonight's topic, I think you guys might have already touched on this based on some of our conversations. But for me, BC starts with what's called integration by parts. So that's the only topic we're going to hit tonight. None of these classes are going to be meant to be like extremely long or anything to that nature. We're just going to hit a topic and we'll take questions on it. We'll try some practice problems on it. Big thing here for you guys is you've got to talk to me. The more you communicate, I'm more than happy to answer questions and stuff. But as we know from the past, it's tricky to learn on Zoom. So make sure you're engaged and asking questions and let me know how I can help. And we will go from there and see how it goes. But don't feel bad. Feel free to interrupt me, start some conversation. Anytime you're not sure about something, just yell out and we'll see what happens. So the first thing we need to know about integration by parts is essentially what you're doing is it's UV minus the integral of V du. And at first glance, you're probably saying, well, what is that? So this is going to be the formula for when we integrate. And typically integration by parts, for the most part, is two things multiplied together is usually what we're talking about. Integration by parts, all of these things are going to be two things multiplied together. And so this is our formula. And the next thing you'll see here that we need is we need to make a list. So this is kind of like substitution, just different train of thought. And we're going to make U du V dv is going to be our setup. And the two things that we are going to select is the U and the dv. And usually the question becomes, what do we take for U? What is the thing that we select for U? And we've got a little thing over here. Okay, Liate, or however you want to pronounce this, Liate, is going to be our anagram for how we make that decision. And this is going to stand for anything with a logarithm, anything with inverse trig, anything that's algebraic, regular trig, and exponential. Okay. So this is the list in order that we're going to jump down from top to bottom. So the second we see one of these, the first one of these that we come across is going to be how we choose U. So if we're choosing U, we're going to go down this list of LIATE, and we're going to see what we come up with. Okay. So does anybody have any questions up to that point? All right, so let's jump into an example. So as far as this goes, this is just a method of integration. This will pop up a couple times on the AP exam. You're going to see a messy integration, and you've got two things being multiplied together. Usually that's what we're going to be talking about here. So it's a BC only topic. So let's say that we have the integral of x to the third natural log x dx. And we want to integrate. So again, the first part of the battle is just recognizing, okay, it's two things being multiplied together. U substitution's not going to work here. How do you know U substitution's not going to work here? Well, the reason I would know that is that one of these variables is x to the third. One of them is only x. So when you take the derivative of one of these, it's not going to cancel out the other one. So U substitution only flies when the exponent is 1 degree off from the other one, so that when you go like U to U dx, you can set those up and stuff will start to cancel. So this is two things multiplied. So we're going to say, all right, we need to make our list. U, du, v, dv. Okay, so how do we choose U? We are going to go down this list. Now, when I say logarithm also includes natural log. That is a type of logarithm. So it doesn't take us long to go down our list and say, okay, the first thing up is a logarithm. So that is what we are going to choose for U. So for U, I'm going to choose natural log x. And whatever the other term is, that is going to be my dv. Now, we have to fill in this box. So how do I go from U to du? I take the derivative. So the derivative of natural log is 1 over x dx. Now, on the flip side of this, how do I go from dv to v? This is the derivative of v, and I want to backtrack to v. Whereas over here, when I went from u to du, I took the derivative. To go the other way, I'm going to integrate. So if I integrate this, that's going to send me backwards. That's going to be x to the fourth over 4. Now, something we need to tack on just to be appropriate with our symbols and our writing. When you take the derivative of v, you get x to the third, but it's x to the third. And we need to just put that dx there with it so that we have everything situated correctly. Okay, so we have the setup now ready to go. Do we have any questions up to that point?
Yeah, why? So if you're integrating, why is there no plus c there?
So because we're just doing that one term individually, and the plus c for this problem is going to pop up when we actually go toss all of this in. So right now, we're going to just go one term at a time, and the plus c, I mean, technically you could put a plus c there. It's just we're only interested in the overall big picture. So currently it's not needed in order to come out with that. That's a good question. All right, so let's toss some stuff in. So the formula is, and it never hurts to write the formula down, uv minus the integral of v du. That's what we're working with. So now we need to plug all of this in, and that formula is from up above. So u is natural log x. I'm going to put it in parentheses too. V is x to the fourth over 4. All right, we've got uv minus the integral of v du. Du is 1 over x dx. All right, so let's take a look at that setup again, make sure that this is making sense. So it's uv minus the integral of v du. So we go right off of our list over here. We've got a box of sorts, however you want to call that. And we plug this information in. So uv minus the integral of v du. First thing I'm going to do is I'm going to simplify this. So this is natural log x, x to the fourth over 4, minus the integral. If we simplify that, that's going to be the integral of x to the third over 4 dx. So we can smush these two together, and these x's would cancel so that we have x to the third on the top. Okay, nothing to do here, but now this is something that we could integrate. So if I integrate x to the third, it becomes x to the fourth over 4. But now we already have a 4 down here. Or if you want, you could think of it as taking 1/4 out front. But either way, this is going to turn into x to the fourth over 16. So when we go and do this, now we're going to actually integrate. So that's natural log x, x to the fourth over 4 minus x to the fourth over 16. And here comes our plus c. Okay, so add 1 to the power, divide by the new power, and you've got x to the fourth over 4. But since there was already a 4 down there, we've got 16. And that's it. You're done. But now, since we're just learning, it's good that we can kind of do a little proof here to check this out. So that's going to be our answer. But now, what do we know about integrals, right? From all the way back at the beginning, what do we know about integrals? The integral of f prime is equal to f. So whatever you get for an answer, you should be able to take the derivative of this and get back to where you started. So in theory, if we take the derivative of this mess, I should end up back at the beginning. Now, you don't always have to do that, but while we're just kind of starting to learn, it's not a bad activity to kind of try. So how do I take the derivative of this? These two are being multiplied together. So that would be a product rule. So let's try it. So we'll call this the test. So the product rule would be, first, derive the second is going to be what? Bring the 4 out front. Those would cancel. So that's x to the third. First derive the second plus the second derive the first. Okay, minus, and then the derivative of this, if we bring the 4 out front, that's going to be 1/4 x to the third. And then our c would drop out. Okay, so that's natural log x, x to the third, plus this term here simplifies. X to the fourth times that, that's really x to the third over 4. And x to the third over 4, that's the same thing as this term right here, right? That's the same thing as just saying this. So these two guys cancel, and then check out what we're left with. We're left with natural log x, x to the third, natural log x, x to the third. So that's kind of showing you that, okay, this crazy formula does in fact work. So recapping all of that craziness, we just said that when you have two things being multiplied together and we are integrating, good strategy is to try integration by parts. And that formula is uv minus the integral of v du. To choose our u, we're going to use this list right here. And then we make a list of u du, v dv. We choose u and we derive it. The other term is dv and we integrate it. And then into this formula, you plug in and see what you come up with. Any questions on that?
For the answer, how much do we have to simplify?
This is good right here. What's in the box, that would be a winner.
Okay.
Okay. All right, let's then try the integral of sine x natural log x dx. Okay, so just remember, I want to make sure you guys all get started on the right page here. So a lot of what we do in these night sessions is going to be, I teach you something, and then you're just going to try a few of them and take some time to practice, and we'll just see how it goes. So as far as tonight goes, this is the lesson, integration by parts. So we're just going to practice some of these and see where it goes. So you need to make a list of u, du, v, dv. And we want to make sure that we get the right letter U before you get to go do all this math, because that'd be crazy. So just remember Liate is the order that we're going to try this stuff in. And the second you see a log or a natural log, we already know that we've got the winner. So you're going to let U be natural log x, and then that makes sine x dx your dv. Okay. All right. So with that all being said, it is 8:51. I will stay quiet for about, I don't know, 4 minutes or so. If you are watching the video recorded session of this later on, you might want to fast forward because there's going to be about a 4-minute break here. So at 8:55, I will hop back on and start talking. So try it and see what you get. Okay, let's see how we did. So if you had natural log x for your u, that is going to make du 1 over x dx. So that's going to make v. Now we need to take the integral of this. So negative cosine x. So when we do that, does that check out? The derivative of natural log x is 1 over x. Derivative of cosine is usually negative sine. We're throwing in a negative sign to compensate. Okay. I would always advise you guys to write the formula out. That's just me because it's a pretty messy formula. So this is going to be equal to uv minus the integral of v du. Okay. So u v minus the integral of v, and then du is 1 over x dx. Did we do that right? Oh, something feels off. Oh no, did I copy this problem wrong? Hold on, guys, this feels off. Did you guys have trouble with this? Taylor, I see you nodding your head. Hold on, I think I copied this wrong. This feels weird. Da, 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 da. Yeah, I copied it wrong. Sorry, and we're recording this. Guess we're gonna have recordings with mistakes. Natural log. This is supposed to be natural log of cosine x. Sorry, I was looking in the wrong spot. This was supposed to be natural log of cosine x. All right, so let's, unfortunately, we're going to need to adjust and do that again. So instead of natural log x, we're going to make that natural log of cosine x. So then the derivative of that would be the derivative of x over x. So the derivative of my stuff over my stuff. So negative sine x over cosine x. Plugging that in, we've got, let's just scrap this whole one. U is natural log cosine x. V is negative cosine x minus the integral of v du. All right, I'll give you a second to catch your breath there. Taylor, the only change I made was this was instead of this being natural log x, we changed it to natural log cosine x. Okay, so when you take a look over here, the cosine x's can cancel out. And now we have natural log cosine x times negative cosine x. How many negative symbols do you see here? I see 1, 2, 3 negative symbols. So that's really going to be minus the integral of sine x dx. Question in chat, why did I do negative cosine here? So when you're going from here to here, you're integrating, right? So you're saying if dv is sine x and I want to go back to v, you're taking the integral of sine. So off to the side, if this is your thought bubble, the integral of sine is equal to negative cosine. The thing that I said you were compensating for is that the derivative of cosine is negative sign, but then we toss a negative symbol onto it so that it checks out to be positive sign. Okay, so we need to integrate this and we've got it. So this is natural log cosine x times negative cosine x. Okay, the integral of sine is going to be negative cosine. And then I'm going to just change this to a plus. And we've got it. These answers are kind of messy, so they don't feel as natural as regular integration as you're used to. So when you go and do it by parts, the answers you end up with are a little long, little messy. So sorry about writing that incorrectly to begin with. Do we have any questions there? All right, let's try again with a problem that is copied correctly and see how that works out. So here is a very popular one. Maybe you can put a star by this. I have a hunch you see this. It's on most of the BC exams. They tend to throw an inverse trig integral on there. So if you see this, it could be inverse sine, could be inverse cosine, could be inverse tangent. I would say real strong chance they throw one of these on there. The trick to integrating this, if you see one, is that you have to rewrite it as 1 times the inverse trig function. You have to add in that times 1. It's a little trick in order to make this work. And now you're ready to go. This is going to be done by parts. Check out your list, LIATE. So do we see any logarithms? No. Next up, I. What does I stand for? Inverse trig. Sounds like a winner. So we are going to make our list of U, du, v, dv. And we just said that u is going to be the inverse trig. And that's going to make dv 1 dx. Okay, I will stay quiet for a little bit, see how you do. As a hint, when you get going, when you get to the part where you're trying to integrate, so we know the formula, right, is uv minus v du. When you get to this piece over here and you've plugged stuff in and you're ready to integrate, some of these problems require u substitution. This is one of them. So you're going to get some wild thing over here to integrate. You have to know u substitution in order to get through this mess, okay? So keep that in mind, and off you go. We'll talk in a couple minutes.
Would it be correct to say the antiderivative of 1 is x?
Yep, that's correct.
Thanks.
Okay, so we need to know the derivative of inverse sine. Are we good with the derivative of inverse sine being 1 over the square root of 1 minus x squared? Any questions on that one? So we're good on those ones. Okay. And then backtracking over here, that would take us over to just x. Okay, so plugging this in, we're going to be at uv minus the integral of v du. So u is inverse sine x. V is x. So uv minus, kind of have to talk to yourself a lot when you're doing these because there's so much stuff going on. Uv minus the integral of v du. And du is 1 over radical 1 minus x squared dx. Okay, so we've already given you the hint that we're going to do u substitution here. So this is inverse sine times x minus, and this is really x over the square root of 1 minus x squared dx. So to integrate this piece, we need to do u substitution. To do u substitution, it's u du dx. So we should be choosing 1 minus x squared. So that is negative 2x dx. So that makes dx du over negative 2x. Okay, so we're going to toss this in. So we've got our first piece. All right, minus x over u to the half du over negative 2x. So that's looking good. The x's are going to cancel. I take out a negative half. The x's are going to cancel, and I take out a negative half. So I'm going to change that to plus because we already had a negative out there. So plus half integral, and then to integrate 1 over u to the half, we're going to flip that upstairs to make that u to the negative half du. Okay. Okay, so integrating that, we've got inverse sine x plus half. And then when we integrate this, this is going to be u. If we add 1, that's u to the half over a half, but divide by half is like multiplying by 2. And then that means this half and that 2 are going to cancel. So that's going to be inverse sine x plus u to the half plus c. Final answer. All right, so that's a little bit much. Do we have any questions on that one?
How many times can it be like within the same problem? Can you like integrate parts, and then it like do
Yeah, so you can technically, there's some of these, I mean, depending where you look, some of these problems are outrageous. This is about as messy as anything gets on an AP exam. You don't typically have to go through anything any crazier than this. And then there's also some other tricks that you'll learn, some things called tabulation and some stuff for cases where stuff gets really wild. But in terms of like this is pretty much as far as you would need to go. And then, yeah, there's also some other tricks you can do with trig substitutions for stuff that's crazy. In general, it's usually the thing that's good about BC is it's a lot more material, but all the BC problems are like very predictable, very straightforward. It's just like, whereas the AB stuff, it's anybody's guess what they ask you. The BC stuff, it's like very predictable. Like there's going to be a parts problem. There's going to be a partial fraction decomposition. It's very, very particular. Like every single topic that gets taught in BC, you kind of just see like one of them and you keep on going. So it's just a whole bunch of extra material, but it's usually pretty straightforward. All right, so I don't want to keep you guys forever. Let's do one more start to finish integration by parts problem. This seems like a pretty good one to try, these inverse trig ones. And then we'll wrap it up for the night. So we'll be done here before 9:30 tonight. And let's finish with, let's have you guys try inverse tangent.
What is the derivative of inverse tangent?
It's 1/x² + 1.
1/. Okay, thank you.
Okay, so we should have our chart here of U, du, v, dv. All right, so if we pick our u, we're gonna be, and the other thing is we need to rewrite this rate as 1 times tangent, inverse tangent x. So our u is gonna be inverse tangent x, and that's gonna make our dv 1 dx. That makes that x. That makes that 1 over 1 plus x squared. All right, so we got the setup, and now we're gonna go plug these in. So this is gonna be equal to u v minus the integral of v du. All right, so this is going to be the integral of x over. All right, so we need to do u substitution for this. So to do our u substitution, we're going to do u du dx. So we're going to go 1 plus x squared. So that is 2x dx. So dx is du over 2x. All right, so we've got inverse tangent x, x minus the integral of x over u du over 2x. The x's will cancel and we're taking out 1/2. So this is inverse tangent x times x minus 1/2 integral 1 over u du. Okay, so we need to make sure we know how to integrate 1 over u, so that's a special case. So we've got inverse tangent x times x minus 1/2. The integral of 1 over u is natural log absolute value. So 1 plus x squared plus c. And that is it. You got a final answer. Do you have any questions on that? Okay, so we will, if you've had me before, you guys know how I teach. If you haven't, I tend to always incorporate all the things. So you'll see one integration by parts problem almost most nights or on every review I give you and this and that. So just take good notes, document everything we do, but this particular piece is called integration by parts. So I'll continually always throw one at you whenever we meet and stuff, but that's the gist of it. Two things being multiplied together, and then you got to know the pattern for that. So any questions there? All right. So the plan is right now, again, we're starting very early. So every week it'll vary slightly. So I'll keep you up to date. So tonight was Sunday, and this was Sunday from 8:30 to 9:30. So we're going to plan to meet tomorrow night from 8:30 to, it seems like an hour is a reasonable time for these. And then also planning to do Thursday this week from 8:30 to 9:30. Okay. So this has been recorded, so I will hopefully be able to get these posted on Canvas. Do you guys have any questions? All right, one lesson down, many more to go, but we will get you there. So good job. Thanks for coming. We will see you next time.
Thank you, Mr. Baker.
Thank you, Ms. Baker.
You got it. See you guys.
Thank you. Bye.
Yep. Bye-bye.
Thank you.
Thank you. Bye.
Bye-bye.
Thank you. Good night.
Have a good night.
Mr. Baker, can I
What?
come take the test tomorrow?
Yeah,
during
I'll be,
advisory?
yep, I'll be there.
Thank you.
Okay.
Okay.
Advisory.
Yep,
Okay,
I'll-
I sent you a remind also. I don't know if you saw it, but it was like.
Oh, and I must have missed it. Yeah, I'll be there in
that's fine.
advisory. The advisory works. I'll see you guys then.
Okay. Do you want to come during flex or at the start?
Whatever works for you.
Okay, cool. I'll probably be at the start. Okay,
Sounds
cool. Have a good night.
You too.